Okay, let's unpack this. We are diving deep into a celestial mystery that, it completely captivated astrophysicists, government agencies, and basically every headline writer across the globe for the back half of 2025.
It really did.
We're talking about a mysterious visitor from the cold, dark void, known officially as 3ILS, or also cataloged as C2025N1.
Indeed. And when we talk about interstellar objects, you really have to understand the context here. For millennia, our entire solar system was defined by objects that were born here.
Right, everything was local.
Everything was local. Then in 2017, we had the first confirmed visitor, 1
The weird cigar-shaped tumbling object.
That's the one. Then a couple of years later, 2I Borisov, which looked much more like a regular comet, but 3ILS, it just amplified the scale of the mystery and demanded a completely new level of scrutiny.
The moment the ATLA survey in Chile spotted it on July 1st, 2025, it seems like all the alarm bells went off. The initial data was shocking. It was big. The early estimates were gigantic. And it was moving so fast, it just screamed anomaly.
What's fascinating here is that the sheer speed defined the entire conversation from day one. It has what astronomers call a strongly hyperbolic orbit.
Okay, that's a technical term. What does that actually mean for us?
It's a fancy way of saying its eccentricity, which is just a measure of how stretched an orbit is, was huge. It was around 6.1.
And anything over 1 means it's not sticking around.
Exactly. Anything greater than 1 means the object is moving way too fast for the sun's gravity to capture it. It's unbound. It's just passing through.
So it's not just passing by, it's screaming through. And how fast is screaming?
It was moving with what we call a hyperbolic excess velocity, or V infinity, of about 58 kilometers per second.
58 kilometers per second.
Per second. To put that into perspective for you, that's about 130,000 miles per hour relative to the sun. That speed confirms it originated outside our solar system, and crucially, that once it leaves, it will never, ever be seen again. This was a one-shot opportunity for observation.
A one-time high-speed visitor.
Yeah.
And because of that extreme behavior, the scientific community had to approach this formally, right? They couldn't just have a free-for-all debate on social media.
Exactly. Its movement was so unusual, we were forced to apply what's known as a formal statistical framework, a really rigorous Bayesian model comparison.
Okay, Bayesian model comparison. Let's break that down.
It's an analysis method that lets you test two mutually exclusive hypotheses against the data. We weren't looking for opinion, we were calculating quantifiable probabilities. How likely is one explanation versus the other?
So what were the two competing ideas on the table?
Hypothesis 1, which we'll call HI-Shen, was the baseline. The natural volatile rich comet. Just a weird rock and ice ball from another star system that happened to be speeding through.
And the other one?
Hypothesis 2, HI-T, was the truly provocative one. The technological object. A probe, possibly cloaked, maybe partially steered, but something engineered. An artifact.
Our mission today is to follow the astrophysicist's journey using those numbers, the Bayes factors, or K values, to quantify the evidence for each side. And maybe more importantly, to understand why the consensus eventually landed so firmly where it did, despite some incredible statistical outliers that seem to favor the alien theory.
And before we get into the nitty-gritty of the evidence, it's probably useful to contextualize how seriously these anomalies were taken. It's useful to introduce the Loeb scale here.
The Loeb scale. Okay, what is that?
It's a measure proposed by researchers who study these interstellar phenomena, and it's designed to quantify the severity of an anomaly, to give a number to how weird something is.
So it's not just that's odd, it's that is a level 4 oddity.
Precisely. So what does a level 1 anomaly look like versus, say, a level 5, the most severe?
Yeah, give me the range.
A level 1 would be slightly unusual, maybe a slightly strange shape, or a bit of unexpected outgassing. A level 5 is something that is utterly inexplicable by any known natural process. Something that demands immediate, dedicated attention, the kind of thing that would truly redefine our understanding of physics or life in the universe.
So where did 3ILS fall on that scale when it was first discovered?
Well, the fact that 3ILS had such strange initial dynamics meant that from day one, it was hovering around a level 3 or 4.
At high.
Oh, yeah.
Yeah.
It was indicating strong dynamic anomalies that must be investigated, even if subsequent data might eventually downgrade it. The scientific community just couldn't afford to ignore it.
Okay, so let's start with that evidence. The stuff that put 3ILS on the Loeb scale in the first place, the dynamical features that made scientists like Dr. Avi Loeb press the case for a technological origin, these weren't just vague feelings. They were driven by incredibly improbable orbital paths.
Absolutely. When an object arrives from interstellar space, you expect its trajectory to be essentially random, an isotropic scatter shot from the galaxy.
Just coming in from any old direction.
Any direction, any angle. The fact that 3I-AS's orbit defied this randomness so spectacularly provided the initial powerful statistical evidence for HET, the tech hypothesis.
So give us the specifics on that first major anomaly. I think the paper called it feature 2, or F2, concerning its orientation.
Right, F2. This involved the orbital plane and its inclination. So first, the object was in a retrograde orbit.
Meaning it was going the wrong way around the sun.
Exactly. Counter to the vast majority of objects in our solar system, its inclination was about 175.1 degrees.
So almost perfectly backward. 180 degrees would be the exact opposite of the planets.
That's right. And retrograde motion itself isn't, that rare for comets that originate far out, way outside the ecliptic plane, the plane that's defined by the planet that orbits.
Okay, so if that part isn't so strange, why was this specific angle considered such a big anomaly?
Because despite moving backward, its orbital plane was nearly coplanar with the ecliptic. Imagine our solar system as a giant flat pancake. A random object might come screaming in from above or below at 45 or 90 degrees. But 3I Atlas came in backwards. It was traveling almost exactly parallel to the pancake itself.
So if you were, say, an alien civilization trying to line up a shot to get a good look at Earth, Mars, Jupiter, and the Sun, that's exactly the kind of alignment you would want.
Precisely. It's the optimal surveillance trajectory. Under standard models that assume random ISO arrivals, models based on, the gravitational kicks they receive from their parent star systems, the chance of achieving this specific, highly aligned retrograde configuration is incredibly low.
How low are we talking?
It was statistically estimated at only about 0.2% likelihood.
0.2%. So 2 chances in 1,000.
2 in 1,000. That's starting to stack the odds.
How did that translate into the Bayesian model? We need to understand what those Bayes factors, the K values, actually mean.
So when we talk about Bayes factors, you should think of it as a quantitative odds ratio. If the K factor is greater than 1, it favors hypothesis HT, the tech one. If it's less than 1, it favors HEN, the natural one.
Okay. So what was the K value for this orbital plane anomaly?
Feature F2 alone yielded a Bayes factor, K2, of approximately 10 to the power of 2.
Wait, 10 squared, so 100? But I saw a number in the outline that was like 150. What's the difference?
That's a great question. It's where the rigor of the calculation comes in. The 10 squared is the order of magnitude, the ballpark. The actual calculated odds ratio was closer to 150.
So what does that mean in plain English?
It means that, based only on the object's orbital plane and inclination, the hypothesis that 3I Atlas was a deliberately positioned surveillance probe was 150 times more likely than the hypothesis that this orientation just occurred randomly by chance.
150 times more likely to be designed just based on the incoming angle? That's staggering for a single piece of evidence.
And that wasn't even the strongest piece of dynamical evidence, not by a long shot.
Okay, what's next?
Now we move to feature 3, or F3, the sequence of close planetary encounters. This trajectory was, it was practically a galactic tourism plan.
Give us the itinerary.
Okay, so its path resulted in a series of really convenient close passes: Venus, Mars, and Jupiter. It passed Venus at about 0.65 astronomical units.
An astronomical unit, or AU, being the distance from the Earth to the Sun.
Right, so roughly 2/3 the distance of Earth's orbit. Then it passed Jupiter at 0.36 AU. Still quite close for such a massive planet. Great for gravity assist maneuver.
But the real attention grabber was Mars, right?
Yes, it came within a mere 0.19 AU of Mars. That is incredibly close. We're talking less than 30 million kilometers. If you plot that specific sequence of close planetary approaches, Venus, then Mars, then Jupiter, it just looks highly intentional.
It sounds less like a random cosmic bounce and more like a carefully planned gravitational slingshot tour to gather data on the inner solar system's architecture.
The statistics absolutely back that up. When researchers calculated the statistical improbability of this specific multi-planet sequence occurring randomly, the number was just jaw-droppingly small.
How small?
Only 0.005%.
Wow. 0.005%. That's 5 parts in 100,000. That's almost impossible by chance.
It's vanishingly small. And that impossibility translated into an even more staggering Bayes factor. This feature, F3, generated a K3 of approximately 2,000.
2,000.
1,000.
Favoring the technological hypothesis, HOT.
So 2,000 times more likely to be intelligently designed than to be a random cometary trajectory. If you were only looking at the orbital mechanics, the case for HT seemed, almost irrefutable. We're talking 3 orders of magnitude of statistical weight here.
And this weight was further bolstered by another idea, the concept of the cloaking trajectory, which covers features F5 and F6.
The cloaking trajectory, that sounds ominous.
It addresses not just where it went, but when it performed its most critical maneuver.
Why does the timing matter so much? So, 3I Alice passed perihelion. That's its closest approach to the sun, about 1.35 AU in late October of 2025. Crucially, during this period, it was obscured from Earth observation.
Oh.
Because of what we call low solar elongation. The sun was essentially blocking our view. It was on the other side of the sunfuss.
It hid behind the one celestial body we can't look past?
Yes. And if you are, hypothetically, a surveillance probe that needs to adjust its trajectory or slow down, that is the single most efficient place to do it while maintaining maximum secrecy.
Okay, I see where this is going.
Under the HT framework, this alignment pointed toward a potential reverse solar O-berth maneuver.
We need to unpack that. What exactly is a solar O-berth maneuver, and why would you ever do it in reverse?
Okay, think of the O-berth effect. It's a principle in astrodynamics that says the closer you are to a massive body, like our sun, and the faster you are moving, the more efficiency you get from firing your engine.
Okay, so you get more bang for your buck.
Exactly. The classic example is, imagine you're on a bullet train and you throw a baseball off the back. You maximize the force you impart because your initial speed is already so high. A standard O-berth maneuver uses this maximum efficiency at perihelion to maximize acceleration and leave a solar system even faster.
But 3I Alice was already leaving at 58 kilometers per second. It didn't need to speed up.
It absolutely wouldn't, which is why we have to consider the reverse O-berth. A technological object might use that high-speed, high-gravity environment at perihelion to apply maximum thrust to slow down.
Why would it want to slow down?
To change direction, maybe to enter an eventual bound orbit around the sun, or perhaps to refine its trajectory toward the outer planets for a better look. And doing this while you're completely obscured by the sun serves 2 purposes: maximum maneuver efficiency and minimal detection risk.
So the argument is, the dynamics, the perfect observational plane, the multi-planet grand tour, and the hidden optimal maneuver point, they all align suspiciously well with intelligent design.
That's the core of the HT argument. And let's not forget the initial size estimates, because that was another major piece of the puzzle.
Right, it was supposed to be huge.
It was. Early calculations before the object showed any obvious cometary activity assumed it was a dense, inert asteroid, kind of like the initial understanding of Oumuamua. Based on its brightness, those early estimates suggested a nucleus size of up to 20 kilometers.
Manhattan size, that was the headline.
Exactly. And objects that large arriving from interstellar space should be statistically vanishingly rare compared to small ones. This initial size paradox was another strong piece of evidence supporting the idea that it wasn't a random natural visitor unless it was highly targeted.
So we have 2 to 3 orders of magnitude of probability, a factor of 2,000. Favoring a highly sophisticated engineered path. So, now let's introduce the counterargument, the one that ultimately resolved the whole mystery.
This is where the entire narrative just shifts completely. If we only had the orbital dynamics to go on, the technological hypothesis would have been nearly impossible to dismiss. But once the object got closer, and our most powerful telescopes could actually get a good look at it, well, the physical evidence was overwhelming. And it anchored 3I Atlas firmly in the natural cometary category.
The key here is activity, right? 1I Oumuamua was notoriously inactive. It was just a rock. But 3I Atlas, it started putting on a light show.
Exactly. Features F4 and F7 in the analysis cover the cometary activity and its composition. Unlike Oumuamua, 3I Atlas displayed clear, sustained, visible activity. It developed a bright coma.
That fuzzy cloud of gas and dust around the center.
Right around the nucleus. And it grew a tail that stretched up to 25,000 kilometers long. This is a textbook definition of a comet exhibiting active outgassing or sublimation.
So if it looks like a comet and it acts like a comet, the simplest explanation is that it is a comet.
That's Occam's razor right there.
But the devil is always in the details of the chemistry. What did the high-resolution spectroscopy reveal when they actually analyzed that gigantic cloud of material?
The initial findings were intriguing. They found a gas coma that was dominated by carbon dioxide, CO2.
Which is interesting because our own solar system comets are mostly water ice, H2O.
That's right. So it was CO2 heavy. But alongside the high CO2, they found significant amounts of water, carbon monoxide, CO, and carbonyl sulfide, OCS.
So it's a weird comet, but it's fundamentally made of the same stuff we'd expect, just in different proportions.
Crucially, yes. But the definitive nail in the coffin for the technological hypothesis came from radio observations. Dedicated radio astronomy searches detected hydroxyl OH lines at specific frequencies.
Hydroxyl, OH lines. Why are those specific lines the smoking gun?
This is the classic cometary diagnostic. Hydroxyl isn't usually found directly on the comet nucleus itself. It is a byproduct. It's the result of the photodissociation of water.
Meaning the sunlight breaks the water apart.
Exactly. When water ice, H2O, sublimates off the comet, it's very quickly broken down by solar radiation into its component parts. Hydrogen and hydroxyl OH. Detecting those OH lines is definitive proof that the object is actively sublimating water ice, a process inherent to natural icy bodies when they get near a star.
So no matter how weird the trajectory was, if you can chemically prove that the engine running the show is just solar heat breaking down water ice, the likelihood of it being a highly advanced cloaked probe just plummets.
Precisely. The chemical fingerprints are overwhelmingly natural. These composition features F4, its overall composition, and F7, the OH radio emission. They generated powerful countervailing Bayes factors. We're talking about K values of approximately 10 to the minus 1 to 10 to the minus 2.
Okay, let's translate that. If the dynamic anomalies were 150 times and 2,000 times for the tech hypothesis, what does a factor of 10 to the minus 2 or 100 actually mean?
It means that the evidence, the chemistry, was 100 times more likely to have arisen from a natural comet than from an engineered object. The combined evidence was so powerful because this specific mix of volatiles, water, CO, and CO2 is basically indistinguishable from the known diversity we see among comets in our own solar system, even if 3I Atlas sits at the really CO2-rich end of that spectrum.
It's the ultimate reality check. The dynamics made us look for ET. The chemistry told us we found a very strange but ultimately conventional piece of space junk from another star.
And this clarity also helped resolve that initial size paradox. Remember those early fears of a 20-kilometer Manhattan-sized inert object?
Yes, that was a key part of the initial HT argument, that it was just too big and too rare to be random.
Well, once the coma and tail were visible, we realized the object was generating most of its brightness through outgassing, not just reflected sunlight from a massive dormant body.
So it looked bigger than it was because it was so active.
Exactly. Images from Hubble and the James Webb Space Telescope were able to constrain the effective radius of the actual nucleus. And while there was still some uncertainty, the nucleus was confirmed to be subkilometer in size in many observations, with the largest estimates putting it around 11.2 kilometers.
Now, 11.2 kilometers is still pretty big for a comet nucleus, isn't it?
It is, but it completely removes the statistical improbability that was associated with a 20-kilometer inert asteroid. Furthermore, when they looked at its structure, the photometric light curve, which is just the way its brightness varied as it tumbled, showed minimal variation over several days.
And what does that tell you?
That stability suggests a structurally robust, stable nucleus, not some unstable engineered craft that's relying on irregular thrusts to keep it together.
So we have a weirdly big, robust, CO2-rich comet that just happens to have the most improbable trajectory possible. How do scientists reconcile the size and the stability with the traditional idea of a fragile, icy comet that should just fall apart?
This is where the astrogeological hypothesis comes into play, and it's one of the most exciting theoretical advances that was prompted by this observation. This hypothesis suggests 3I Atlas is not a loosely bound ball of ice and dust, the typical dirty snowball structure of a comet, but something much, much older and sturdier.
Older? How much older are we talking?
Much older than our 4.5 billion-year-old solar system. The object's velocity, that 58 kilometers per second, it fits really well within the expected distribution of interstellar object speeds. And when astronomers map the likely origin of objects moving at that speed, many are statistically traced back to the thick disk of the Milky Way.
Why is a thick disk important in this context?
Stars in the thick disk are ancient. They can be up to 7 or even 8 billion years old. If 3I Atlas originated there, it has had billions of years for complex, water-driven geological processes to occur in its parent system.
Processes like what?
Like the formation of sedimentary basins.
Wait, hold on. You're saying this object could be a 7-billion-year-old chunk of rock that was once part of an exoplanet's ancient ocean floor?
That is the leading natural explanation for its stability. The hypothesis is that it's a lithified clastic fragment.
Okay, more technical terms. Break that down.
Lithified just means it has been turned into stone through compression and cementation over billions of years. Clastic fragment means it's composed of smaller, broken pieces like compacted, layered sedimentary rock. Think of sandstone or shale here on Earth.
So unlike a snowball comet that would crumble easily near the sun, this thing is built like a brick.
Exactly. This explains its structural stability and its large size. You can get massive sedimentary deposits. In this view, the comet-like activity isn't sublimation from a weak, icy core. Instead, it's trapped water or other volatiles escaping from the rock's mineral structures or from its pore spaces.
So as it gets heated by the sun, that trapped ancient water is released.
Yes, giving it a coma and a tail, but the overall structure remains incredibly robust.
That is a brilliant piece of scientific detective work. The initial size and stability, which seemed to support the idea that it must be an artificial structure because it was too robust for a regular comet, actually ends up supporting the idea that it's a particularly ancient and robust natural relic from an extremely old, wet planetary system.
The strength of the natural explanation is just incredible here. It connects the physical evidence, the robustness and size, with the chemical evidence, the water and CO2 presence, all within a single, elegant natural framework that links it to the galactic archaeology of the thick disk. It all just fits.
So now we have to bring it all together. Let's do the final synthesis.
Okay, now we synthesize all this data, and we have this extraordinary situation where the dynamical anomalies, the plane alignment, the planetary pinball machine, were massively weighted toward HT, the Tech hypothesis, with factors up to 2,000.
Incredibly strong evidence on that side.
But the physical constraints, the detection of water outgassing, were just as massively weighted toward HN, the natural hypothesis, with factors of 1/10 to 1/100th.
So if we connect this to the bigger picture, it sounds like the composition features acted as a kind of statistical sledgehammer that just absolutely crushed the dynamic anomalies.
That's precisely what happened in the Bayesian model comparison. The overwhelming strength and the unambiguous nature of the physical evidence, I mean, the OH signature is really hard to argue with, was so powerful that it effectively canceled out the statistical improbabilities of the dynamic path.
So even though the trajectory was a 1 in 20,000 random shot, the fact that it was physically confirmed to be a comet made that path statistically acceptable as a one-off natural fluke.
That's it. It becomes an outlier, but a natural outlier.
So give us the final statistical verdict. Where did the numbers land?
The combined statistical verdict was conclusive. Even if you start with a very generous and optimistically high probability for a technological object, say you assume PHT starts at 1 in 10,000 or 10 to the minus 4, the combined evidence placed the posterior probability of 3I Atlas being technological at less than 1%.
Less than 1%.
We are talking about 10 to the minus 2 or less. The evidence for a natural origin was overwhelming.
So it is dynamically special, yes, a 1 in a million shot trajectory, but physically ordinary. It's just a comet.
That phrase should be stamped on every single report about 3I Atlas. It's a dynamically special but physically ordinary object. It was officially classified at level 4 on the Loeb scale, but specifically in the context of its dynamical anomalies.
Meaning a highly anomalous orbit, but overwhelmingly resolved by physical measurements as a natural object.
Exactly.
Right, so this cosmic tourist is now speeding away. Where is it right now, and what are we missing as it departs?
3I Atlas passed perihelion in late October 2025 and is now outbound, heading back into the cold dark. It is currently speeding past the orbit of Mars and will eventually exit our solar system in the direction of the constellation Virgo, never to return.
Okay, here's where it gets really interesting and also incredibly frustrating, because the most definitive potential data we could have captured remains elusive. It's a perfect illustration of how scientific discovery is often derailed by completely non-scientific obstacles.
This is the human and administrative side of the story that so often gets overlooked. The absolute best opportunity for a high-resolution, definitive image of the nucleus structure was expected to come from the Mars Reconnaissance Orbiters, the MRO's HiRISE camera.
Why MRO? What made it so special?
Because of that extremely close pass it made near Mars on October 2nd, 2025. That trajectory put 3I Atlas in the perfect position for the HiRISE camera, which is one of the highest resolution cameras ever sent to another planet, to capture it at an astonishing resolution.
What kind of resolution are we talking about?
Potentially down to about 30 kilometers per pixel. This image could have resolved the lithified clastic fragment theory versus a fragile ice ball once and for all. It could have shown us the surface.
This was the shot. This was the one the world's astronomers were waiting for. The image that could have confirmed or denied the physical robustness of the nucleus.
Absolutely. The tension was immense. Researchers had submitted their viewing requests, the MRO team executed the maneuver perfectly, and the data was successfully captured and sent back to Earth. Everyone expected an immediate release of the picture.
But the release was publicly noted as being suspended. What on earth was the roadblock?
This is the bitter irony of the whole situation. The lead investigators team noted publicly that the data release, even by the principal investigator at the University of Arizona, which manages the camera, was on hold.
Why?
Because the U.S. federal government had initiated a partial shutdown.
You're kidding me. A government shutdown prevented the release of the most critical piece of evidence regarding a potential visitor from another star system.
That is what happened. It sounds like something out of a science fiction novel, where the bureaucracy is the final villain.
That's unbelievable.
It was a palpable frustration across the entire astronomical community. The communication protocols for any NASA news had been suspended. Researchers had the data, but they were legally or administratively blocked from sharing it publicly pending NASA approval, which itself was delayed indefinitely because of the shutdown.
It just underscores the fragility of this kind of science. You have these ephemeral visitors, the window for observation is incredibly short, and terrestrial issues like funding debates or administrative halts can cripple a mission's potential.
Absolutely. So, months after the close encounter, the single most definitive picture of the object that raised the highest suspicions of alien technology in a generation is sitting on a server somewhere, blocked by terrestrial paper pushing.
Wow. It's a massive, frustrating missed opportunity for immediate clarity. While the chemical data provided a strong statistical verdict, that visual confirmation would have provided closure for millions of people worldwide.
It really would have. It remains a testament to the fact that science is a human endeavor, and it's susceptible to very human problems.
Putting that frustration aside for a moment, the successful detection of 3I Atlas and the ones before it, it signals a future where these interstellar detections are going to become routine, right?
Without a doubt. The discovery of 3 ISOs in less than a decade shows that they are common. Furthermore, the velocity of 3I Atlas, that 58 kilometers per second, is perfectly in line with what our population models predict for ISO speeds throughout the galaxy. We are simply getting much, much better at seeing them.
And what's on the horizon that's going to truly revolutionize ISO detection?
The big one is the upcoming Vera C. Rubin Observatory in Chile, with its massive legacy survey of space and time, or LSST.
I've heard about this. It's going to be a game changer.
It is. This observatory is predicted to discover interstellar objects every few months, perhaps even dozens a year. This massive influx of data will transform the field completely. We won't just be looking at statistical anomalies one at a time, we'll be studying entire populations of these objects.
So we'll move from chasing individual anomalies to building a galactic census.
That's the perfect way to put it. We will be able to refine the statistics of galactic populations, making the next dynamically special object much easier to categorize because we'll have solid reference data to compare it to.
So 3I8NELS was perhaps the most compelling candidate yet for the technological hypothesis, but it was ultimately resolved as an extraordinarily rare natural comet. If it's not an alien probe, what will be its lasting legacy in the scientific community?
3I-DELS will not be remembered as an alien artifact, but it will absolutely be remembered as a crucial benchmark case. Its primary role was to force the astrophysical community to integrate anomaly hunting into a rigorous, quantitative statistical framework, that Bayesian model we've been discussing.
So professionalize the search, in a way.
Exactly. We can't rely on gut feelings or qualitative arguments anymore when the stakes are this high. We now have a standard methodology for calculating objective probabilities. It proved that the scientific search for extraterrestrial intelligence could be rigorous, not just speculative.
And it showed just how weird nature can be on its own.
That's the other key takeaway. The dynamic features favoring the technological hypothesis were exceptionally strong. We have to remember that. Factors up to 2,000. It demonstrated that objects can, purely by chance, arrive in our solar system on trajectories that look entirely and convincingly designed.
And the natural evidence had to be overwhelmingly conclusive to cancel out that sheer improbability.
It did. The only thing that prevented a major scientific paradigm shift was the completely overwhelming conventional chemical evidence, that smoking gun of water outgassing. That OH signal was our safety net. It was the thing that brought us back to a natural explanation.
And that leads to a pretty provocative final thought, doesn't it?
It does. It raises the most important question, which I think is the enduring legacy of 3I Atlas. What if the next anomalous ISO is inactive? What if it's like Oumuamua, lacking a clear coma and tail, but possessing the statistically improbable trajectory of 3I Atlas?
Without that chemical safety net.
Exactly. Will the community be ready to let the statistics, the highly weighted dynamical anomalies, factors of 2000, guide them beyond traditional thinking, even without the comfort of a clear water ice signature?
If the composition is neutral or ambiguous, the burden of proof shifts entirely back to the dynamic evidence. Evidence that, in this case, already suggested intelligence was the more likely explanation by a factor of thousands. That is the lasting challenge this benchmark object presents for the future of interstellar exploration.
It's the big question.
Yeah.
We'll be ready with the numbers next time.
A fascinating thought to leave you with as we all wait for the next visitor from the deep to arrive. Thanks for diving in with us.
My pleasure.
We'll see you on the next deep dive.